Instrumental variable is such a common topic. I'll write you 2-3 books which you can look at, okay, which can be useful to you. I don't want to restrict you to a single book. Okay, apart from Baltagi, there are 2 books listed in your references. Those 2 books also you can. Have you got your library cards? Yes. Yes. So you can then go to the library and look at these books. Also Google, instrumental variables, etc. Quite a lot of it is there. And in addition to that, you already have these videos which you can look at again. I think Baltagi's book is a good book. You search for your, you are free to search for things on Google. And also the 2 books which are listed in your references. I think that is more than enough for the entire semester, or so far what we have done. Okay? Any other doubts you folks have, please ask me so that, yeah? You see, I realize that when you ask a doubt in a class, what you produce in the class is a public good. Right? Because you can't exclude anybody. It's a non-excludable, non-rival form of production of knowledge. And because it's a public good, we know that the market will supply too little of the public good, and that's why doubts don't get asked in class. Right? So please overcome that and do ask me doubts if you have any. Yeah. Right. That's it. So you get sigma square upon x dash x inverse if the E dash E matrix is sigma square I. If the E dash E matrix is not sigma square I, then you leave it as omega hat, but that's something which I need to deal with you in the module, in the next module, about how does one deal with that kind of a situation. Sure. Yes.
But how do we determine, for example, we had something like summation xi minus x bar yi minus y bar upon n minus 2. But here we wrote n minus 2 is the degrees of freedom. But our condition, the constraints are actually summation xi ei is equal to 0, xi minus x bar is equal to 0, and yi minus y bar is equal to 0. Isn't it 3 conditions?
No, there are only 2 constraints. Because, see, once we have, what do we have? First we have, so you have, say, y1, y2, y3, and you have x1, x2, x3. All right? Now, once you have determined what is y bar and x bar, how many data points can vary? 2. So actually, only one, even when you're setting summation yi minus y bar is equal to 0, summation xi minus x bar is equal to 0, you're only losing out one observation. So, n minus 1. Right? Any more? What is the exact formula for the variance of alpha hat? The variance alpha hat, so basically if I have beta hat, yeah, is sigma square into x dash x inverse. Okay? So now let us understand what is x dash x inverse. Okay? Fine. Which is variance of this. Variance of this is x dash x inverse. But what is the variance of alpha hat minus beta hat 1? It is the expected value of alpha hat minus alpha transpose into alpha hat minus alpha This is what we are interested in. So this will be a 2 cross 2 matrix. The first row, first column will be expected of alpha hat minus alpha square. So the first row, first column of sigma square x dash x inverse will be the variance of alpha hat. Okay. So what is the first row, first column of sigma square x dash x inverse? The first row, first column of sigma square x dash x inverse is the following. So this was this is the first row, first column of x dash x inverse. Sigma square is there. So the first row, first column is sigma square. Yeah. This is yeah. Right? So the first row, first column must be the variance of alpha hat. The second row, second column must be the variance of beta hat. And the off diagonal elements are the covariances of alpha and beta, alpha hat and beta hat.
Is there any different formula for simple regression in alpha hat and multiple regression in alpha hat? Different formulas will go?
No, the formulas will be identical. Except that the formulas are easier to derive in a multiple linear regression context. Because there you know alpha hat is y bar minus beta hat x bar, and y bar is then you have to substitute those and becomes a complicated formula, where this becomes an easier way of looking at it. Sure? Clear, friends? Yeah? No, all that you need to do show is that as the sample size becomes bigger and bigger and bigger, beta hat will get closer and closer to beta. So probability limit beta hat is equal to beta. That is good enough. He wants to know the difference between the law of large number and the central limit theorem. The law of large number says, for example, that as n becomes larger and larger and larger, summation xi upon n will get closer and closer to the population mean mu, which is expected value of x. So x bar will get closer and closer to expected value of x is the law of large numbers. Whereas the central limit theorem says that as the sample size becomes bigger and bigger and bigger, x bar will be asymptotically normally distributed with mean mu and variance sigma square upon n. So the central limit theorem says what will happen to the distribution of x bar as the sample size becomes larger and larger and larger, whereas the law of large number says that x bar will be getting closer and closer to mu as the sample size becomes larger and larger and larger. So that's the second part is the law of large numbers, the first part is the central limit theorem. Yeah? Sure? So are we done? 1 minute, yeah. What? Okay, variance of b hat, beta hat, whatever, yeah.
Can you explain the t distribution? Not the whole thing, just
See, we know variance of beta hat is summation xi minus x bar square. We also know that beta hat is normally distributed with mean beta. Yeah? Sure? From which we know, from this we know must be a standard normal with mean 0, variance 1. Sure? Now, but what is sigma square? Sigma square is the variance of the error term. and we do not know sigma square. So we estimate sigma square by and if you replace this, then this distribution becomes a student's t distribution with n minus k degrees of freedom under the null hypothesis, because an unknown population variance is being replaced by as its estimate from the sample. So the standard normal becomes a student's t with the appropriate degrees of freedom. Right? Are we done? No more doubts? Yeah, please go ahead. Yeah? No, no. A proxy variable is different from an instrumental variable. Okay? Because an instrumental variable estimator will be different from a proxy. In a proxy variable, what do? I do not have a variable x. So I replace it by some variable which I think is y. But I am not sure that this y is correlated or not correlated with the error term. If my proxy variable y, which I am using instead of x, is a variable which is specifically chosen so that it is correlated with x but not correlated with the error term, it becomes an instrumental variable. But if that second condition is not satisfied, that is, I have no way of saying that it is just correlated with x, it is somehow represents x, but is not correlated, the condition that it should be not correlated with the error term is not satisfied, then the proxy will not be an instrumental variable. Right?
So you mentioned that beta has OLS. You're not considering that consistent because in general x and e can be correlated.
If x is endogenous, then x and e will necessarily be correlated.
In general.
Yeah.
Finding out the instrumental variable. In that also we are just assuming that z and e are.
No, we are saying that we have searched and found a variable that is correlated with x but uncorrelated with the error term. Yeah. That's how we have chosen that variable. And the order condition which I talked about helps you actually to find those variables.
So that will for surely be uncorrelated.
Right, absolutely. The chi-square distribution is nothing but a sum of n standard normal squares. We use the chi-square distribution to compare an unknown sample variance with a population, a known sample variance with an unknown population variance. So test hypothesis about population variance is what we use the chi-square for. The f is the ratio of two chi-squares divided by their own degrees of freedom. The difference between f and chi-square is f is the ratio of two chi-squares divided by their own degrees of freedom, and we use the f distribution to compare two sample variances. Whereas we use the chi-square distribution to test hypothesis about a population variance. Because of that theorem which says that s square upon sigma square into n minus 1 will be a chi-square with n minus 1 under the null hypothesis. Right? Everybody understood that theorem well? Right? That's a very simple theorem, so it's not really great shakes. Sure? Everybody is confident? More than the exam, I want you to have internalized all this because this is all very important for your, for applying those things. Right? So do you feel fairly clear about what you have studied so far? Right? Okay? So thank you folks for listening carefully to me, and all the best for your exams.